Folks, we're going to move on in Chapter 3, Parallel and Perpendicular Lines, Part 1. So just a reminder what we're going to be doing in this whole unit, visualizing parallel and perpendicular and skew lines and segments and all that stuff, naming angles when two lines are cut by a transversal, done. But this unit, what we're going to get into is this lesson, we're going to get into the properties of parallel lines, including when cut by a transversal, and we're also going to jump into some parallel line theorems, and that's what this lesson is mostly about. So in the textbook, yay textbook, we're going to be dealing with the Chapter 3, Section 2, properties of parallel lines. And so the first thing I'm going to do is tell you that, well, I'm accompanying that PowerPoint. And so the PowerPoint really goes through the textbook here. We have our Postulate 3.1, which I feel is more like a theorem, but whatever, because it's an if-then statement. So basically it's about corresponding angles. If a transversal intersects two parallel lines, and that's a big if. We're going to be using this quite a bit. If a transversal intersects two parallel lines, then corresponding angles are congruent. And this is where we're going to start this whole thing. Okay, so if you take a look at this diagram here and all that stuff, but let's jump in to an example. Okay, so the example 1, we're going to be identifying congruent angles, and there's a little diagram. And so the question is, which angles measure 55 degrees, and how do you know? Okay, so it's the same question that's here in the textbook as well. Okay, so which angles measure 55 degrees, and how do you know? So, well, let's take a look. Now remember that theorem, or the postulate about corresponding angles being congruent. First thing off is, well, do we know, are we dealing with parallel lines? Do we know that? And we may or may not know. So let's first establish this. You see this? You see this? That means we're dealing with parallel lines. Okay, so whenever you see that symbol, you have to know we're dealing with parallel lines. Okay, so the arrows, there's only one arrow each, so those lines are parallel to one another. So we've established that those two lines are parallel. And if those two lines, it doesn't matter if they're parallel or not, but if those two lines are there, what is this little line called? That is our transversal. So make sure you're good with your academic vocabulary. Okay, so these two arrows means we're dealing with parallel lines, and this is the transversal. So now we know which angles measure 55 degrees, and how do you know? Well, what did we just learn? We just learned that if two parallel lines are being crossed by a transversal, if a transversal intersects two parallel lines, corresponding angles are congruent. So we have to remember which angles are corresponding. So I've been saying in class, the vocabulary is not so much about the words, but where do your eyes go? So where are our corresponding angles? If we're dealing with 55, guess what? Angle 7 is also 55. Why? Because there are corresponding angles. Okay? And they're parallel lines. Okay? So if a transversal is cutting parallel lines, or a transversal is intersecting parallel lines, corresponding angles are congruent. Okay? But now, what else? Is there anything else that might be 55? What else do we remember from days past? If we know angle 7 is 55, what else do we know? And hopefully, you're looking for this, a little blast from the past. What about, this black pen is horrible. What about vertical angles? Okay, so we got to remember vertical angles as well. So we can't remember, or we can't forget about vertical angles being congruent. We already learned that from the previous lessons, okay, so from the previous unit. Vertical angles are congruent as well. So if 55 is here, and 7 is corresponding, well, that means 1 is also 55 because vertical angles, and 5 is also 55 because of vertical angles. Okay? So how does that look in the textbook? Just so you know. Okay, so just so you know, how does that look? Well, this is how we read what's happening in the textbook. We have our little diagram, right, in the textbook. It's the same diagram, but then it's going to go over the definitions, right? So measure of angle 7 is 55. That's what it means. The measure of angle 7 because the corresponding angles. And then the measure of angle 1 is 55 because of vertical angles. Now check this out. The measure of angle 5, they're going to say angle 5 is 55 because it's corresponding to 1. Okay, so basically I just showed you the other way of doing it. Okay, which leads to this next question here. In problem 1, can you find another way to justify the measure of angle 55, or the measure of angle 5? So how can we justify angle 5 being 55? Explain. So here's angle 5. How do we know it's 55? Well, it's vertical to 7, right? So it's vertical to 7. And 7 corresponds to 55. But it's also corresponding to 1. Okay, so angle 5 also corresponds to 1. And that's how we can prove it. There's two different ways. We can show that angle 5 is 55. And how come 1 is 55? Because 1 is 55 because it's vertical. Okay, so we have to find out how we're doing that. Okay, so let's read this next question. This is a fun question. By using linear pairs, hopefully you remember that. Linear pairs, what does that look like? Okay, two angles that form a straight line. It's a linear pair. Okay, by using linear pairs, find the measure of angle 4, and then which other angles have that measure. How do you know? So let's take a look at this picture. Okay, we look back at this picture. Do we see a linear pair? And hopefully you see a bunch of them, but let's look here. Now, angle 4 is a linear pair with that 55-degree measure. Okay, so how do we know? What do we know about that? We know that angle 4, or the measure of angle 4, right, if we add 55 to it, what are we going to get? If we add 55 to the measure of angle 4, you best know this, we're going to get 180. That's what a linear pair means. Linear pair are supplemental, and supplemental angles add to 180 degrees. You have to know that, in case that's all vocabulary as well. So how do we find the measure of angle 4? Very simply, we subtract 55 from both sides, or subtract 55 from 180, and we find out that the measure of angle 4 is, in fact, 125 degrees. Okay, so we now know the measure of angle 4. So using linear pairs, find the measure of angle 4. Done. 125 degrees. Okay. Now, which other angles have that measure, and how do you know? So back to the diagram. Which other angles have that measure? How do you know? So if 4 is 125, what else is 125? Well, let's use old stuff. Vertical angles is 2. Vertical to angle 4. That's also 125. What about 6? 6 corresponds to 2, right? Corresponds to angle 2 is also 125. And 8 corresponds to 4, or is vertical to 6, whichever floats your boat. Okay? So there are many different ways that we can do that. Okay, so which other angles have that measure? So we can answer this, well, we know it's angle 4 is 125, but also angle 2, angle 6, and angle 8. And that's how we would write that down. You know what I'm saying? So that's that as well. Okay? Okay. So now what we're going to do is move on to the next thing. As you can see, we have a couple other theorems that are happening here. So 2 more theorems. We've got an alternate interior angle theorem, and we have a same side interior angle theorem. You got to know what that means. And look how they both start. They both start the same way. If a transversal intersects 2 parallel lines, transversal intersects 2 parallel lines, magic begins to happen if a transversal intersects 2 parallel lines. So the proof that we're going to check out is this proof here. We're going to prove the alternate interior angle theorem, okay, which is the theorem 3.1. So what we're going to do is take a look at this theorem, the alternate interior angle theorem. Transversal intersects 2 parallel lines, then the alternate interior angles are congruent, right? 4 and 6 are alternate interior, 3 and 5 alternate interior. If you don't know that, you better hit pause right now and go check out the previous video from chapter 3, section 1, okay? So what we're going to do is have some fun. Let's prove that alternate interior angles are congruent, okay, when the 2 lines are parallel. So basically, I want to refresh your memory on how proofs work. Okay, so how does that proofs work? In the textbook, here's the same question, right? It's there in the textbook. So we have the alternate interior angles theorem. We're going to prove that it works, that angle 4 is congruent to angle 6. Now, what we're going to be given is that line L is parallel to line M. That's given. So how do we start a proof? We start with a statement and a reason. Okay, remember how that works. And then what we're going to do is go line by line. All right, so the first line, we always start with a given. Line L parallel to line N. How we know? It's given, right? Boom, 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 given. It's always the first thing. Now, if we know that these two are parallel, we know something else. We should know something else about angle 6 and angle 2. What do we know? We know that if lines are parallel, corresponding angles are congruent. That first postulate we dealt with, right? So we totally know that. So now we know 2 and 6. We know 2 and 6 are congruent. Now we go down line by line. Line by line. So the next thing we can see, if we know about 2 and 6, what else do we know about? We know about 4. Okay, we know about angle 4. Come on, Barnard, hurry up. Speaking of getting on, move. Okay. So once you know about 6 and 2, we now know about angle 4. How do we know about angle 4? Because they're vertical. Because they are vertical. Vertical angles are congruent. Blam, blam. All right, but still, what are we trying to prove? We're trying to prove angle 4 is congruent to angle 6. But look at what we have here. Do you see what's next? I hope you see what's next because we're done. Angle 4 is congruent to angle 6. How do I know? Transitive property. If 6 and 2 and 4, then 6 and 4. Transitive property of congruence. So make sure you're using of congruence. Okay? So that's how we can use a proof. Remember, proofs are not going away. And since proofs are not going away, let's have fun with another one. Okay, let's take a look at this. I want you to see in this next proof. If I tell you that A is parallel to B, right? These lines are parallel. What we're going to do is prove that angle 1 and angle 8 are supplements. Okay? Angle 1 and angle 8. You see them? Here's angle 1. Here's angle 8. We're going to prove that they're supplementary. So how do we do that? You can read about the plan and stuff, but I'll explain. Now, a proof, we're setting up statements and reasons, right? And what do we start with? We start with given. What's given? A is parallel to B. Now, once we've established that, we know a bunch of things, okay? Once we establish that, we know a bunch of things. What do we know? We know same side interior angle theorem, right? We know this. Same side interior angles are supplementary. They add to 180. And we know that alternate interior angles are congruent if the lines are parallel. And we know that corresponding angles are congruent if the lines are parallel. We know all that stuff, right? So we have all of these weapons at our disposal to prove our point. So we start with the given, parallel. A is parallel to B. So what do we now know? Look at the diagram. If we know A and B, guess what we're given? We have 5 and 1, right? You see 5 and 1? Totally corresponding. So angle 1 is congruent to angle 5. How do we know? What's the reason? If lines are parallel, then corresponding angles are congruent. So we can totally use that. Okay, we can use that first postulate. All right, but what we're trying to do is get to angle 1 and angle 8. We have angle 1 and angle 5. Can we access angle 8 from anything? Yes, we can. Take a look at this next step. We can show that the measure of angle 1 is equal to the measure of angle 5 because we're about ready to get mathy on you. Now, how can we make this step? Well, because we know congruent angles have equal measures. We have to go from congruence to equality. See that jump? Very good jump. From congruence to equality. We have to make that jump. Why? Because this next step. Angle 5 and angle 8 are supplementary. How do we know that? That is not given. So we have to be careful. This step is not given. This step is because they're a linear pair. Okay? These angles are a linear pair. Which you could have inserted that if you would like to. You could have inserted a given by saying angle 8 and angle 5 are a linear pair, that's given, and then give me line 4. Totally legitimate, but we don't need that because it's there. We already know it's a linear pair. Okay, so now we know that those two are supplementary. Let's throw some math on that bad boy. If they're supplementary, the measures of the angles add to 180. That's the definition of supplementary. And if that's the case, guess what we can do? If the measure of angle 1 and the measure of angle 5 are equal, here's the measure of angle 5 and the measure of angle 8. Guess what we know? Angle 1 and angle 8. We can substitute angle 1 for angle 5. Look what just happened. I want you to see this. We can substitute angle 1 for angle 5. Why? Because of this. And we can use substitution. Okay? Angle 1 from angle 5. Why? Because we substitute it. And why would we want to say this line to begin with? Because look at back up and what are we trying to prove? That they're supplements. And now we are done, basically. Angle 1 and angle 8 are supplementary. How do we know? That's the definition of supplementary. How can we say this? Because, well, they add to 180. That, by definition, is supplementary. Okay, so we are definitely in proofs. We're totally doing proofs right now, and that's important to know. Okay, so let's use some of this stuff. Let's use everything we know, and let's have some fun. Okay. So the quick question is, for this particular example, what are the measures of angle 3 and angle 4, and how do we know? Which theorem of postulates justifies this? So here's what we're given. We have an angle here. What's 3? What's 4? So we have to remember a couple of things. The first thing that we remember is that same side interior angles, if parallel lines, by the way, let me yell, if parallel lines, same side interior angles are supplementary. Supplementary. That means they add to 180. Okay? So the same side interior angles are supplementary. So if we look at 105, do we have a same side interior angle? And so we have to pay attention. Here's a line. Here's a line. They are parallel. Okay? Here's a transversal. Now we have same side interior angles. So they are supplementary. That means angle 4 plus 105 is equal to 180. That means angle 4 is equal to 75. Okay, that's what that means. We just subtract 180. Okay, so we have just established angle 4 is measured 75. Now, what is the measure of angle 3? Okay, so angle 3 is the other question. Again, take a look at our lines. So now we have this line and this line are parallel. Okay, this line and this line are parallel. That's what that symbol means, right? Two lines, two lines. Cut by a transversal, now we see these two. Those are alternate interior angles. Okay, so angle 3 is equal to 105. And that is alternate interior angles. So we can look at that in a bunch of different ways. Okay, so that's how we can totally approach that. Now, for a neat thing that you can do with this problem is finish the rest of these, right? Label the rest of the angles. And that'll be a fun activity to do, but I'm going to move on. So let's do some algebra now. Let's take this and throw some algebra on this stuff. So now we're jumping into the algebra applications, and then we'll be done. So here's a problem that's a fun one. We have the example I'm trying to give you here. Right? So finding an angle measure, what's the value of y? Okay, so let's pay attention to what's happening in this diagram. We have two parallel lines. Do you see that? And those two parallel lines are being cut by a transversal, or being intersected by this transversal. So these two lines are parallel, transversal. What do we now see? Hopefully you now see same side interior angles. Do you see that? Those are same side interior angles. All this vocabulary, cats, you're killing me. So same side interior angles. Now what do we know if these are parallel? So these two angles here, if they're parallel, that means the same side interior angles add to 180. They're supplementary. So that means these two angles, this 80 plus blank is equal to 180. But what is this? What is this angle? Right? So now we have the old angle addition postulate. Remember that? So now we have the angle addition postulate. That means if I add y plus 40, I get the other angle. Okay? So this is the hard step right here. I have to remember the angle addition postulate. It's y plus 40 here. If I add that to the 80, because they're same side interior angles, these are parallel. Same side interior angles are supplementary. They eat all this stuff. Right? So some fun. Now we can find the value of y. So first thing we do is combine like terms. 80 and 40 happens to be 120. So 120 plus y equals 180. All we do is subtract 120 from both sides. Subtraction property of equality. Then we have y equals 60. We totally found the value of y. Okay? So that's how we could do throw some algebra on that bad boy. If I went too fast, pause it, rewind. Right? But this is the hard part. Same side interior angles. Recognizing these are parallel. This is our transversal. Same side interior angles are supplementary. Angle addition postulate, this angle here consists of both the 40 degree and the y degree measure. Okay, so that's the hard part. So we're pulling in all this old stuff. You know what I mean? You know what I mean? Okay, good. Last one, and then we will just do some practice or probably call it a day. So this is a fun one. We're going to find some angle measures. Take a look at this picture, right? Hopefully you notice this. That means these two lines are parallel. Yes, they're trapezoids, but these two lines are parallel. So take a look at this. What we're going to do is find the values of x and y. Okay? So we have our trapezoid, whatever, but these two lines are parallel. So what does that mean? That means if we look at this side as a transversal, guess what we have? We have same side interior angles. Okay? Same side interior angles. And if these are parallel lines, same side interior angles are supplementary. That means they add to 180 degrees. Okay? So we have to remember that. So now we have an equation to solve for y. That means we know 3y plus y plus 20 is equal to 180. Hard part, done. That's the hard part. The rest is algebra. Combine like terms. 4y plus 20 equals 80. Subtraction property of equality. 4y equals 160. Division property of equality. Y equals 40. Okay, we've just now solved for y. But what about x? Okay, what about x? Same thing. Okay, very similar. Except for this one, you want to see this as the transversal. Okay, so here's your transversal. That means we have an angle here and an angle here. Guess what? Same side interior. Okay, you have to be able to see that. This is vocabulary all busting out, which means that those two are supplementary. Okay, so we have 2x plus x minus 12 is equal to 180 degrees, and we can now solve for x. Okay? Okay, so 2x plus x, 3x, then minus 12 equaling 180. So 3x equals 192. Addition property of equality. Therefore, x equals 62. Okay? 19 divided by 3. 62. And that's how we solve that. Now the rest is find the actual measures of the four angles in the figure. All we do is plug them back in. Okay? So the rest is work on your own. The rest is lesson check. Be sure to ask me questions and check your answers in the back of the book. And you should be hunky-dory. Okay? So that's it for this particular lesson. You should be good with the introduction to parallel lines. Peace. I'm out.